Welcome to the Chapter 12 Quiz 1 review explanation of the answer key. So again, at this point, you should have submitted your review and then use this video guide as well as the PDF of the answer key to go over your review, make any adjustments or corrections as need be, and then let me know if you have any questions prior to the Chapter 12 quiz number 1. So as I go through this review, I'm not going to go through every step of the work because you'll see it laid out for you, but I will just kind of cover some general notes, things that you want to keep in mind. So again, the first part is as you go through the quiz and review, just make sure you read the directions carefully so you don't miss any credit or any points for missing parts of questions, such as later on stating the domain and range as well as graphing. But in the first two problems, it just asks us to evaluate each expression, which means solve based on the information. So we're going to take the number after the semicolon in the first problem 9 and plug it in for x, and then follow the order of operations to get y. And then in number 2, we'll be plugging 8 in for x, and then following the order of operations as you can see below to get y equals 9. For 3, 4, 5, and 6, these are the problems with graphing radicals and stating the domain and range. So remember, for domain and range, it is always going to be x is greater than or equal to, and then y is greater than or equal to or less than or equal to for the range. So domain is always using an x, range is always using a y value. There's a couple different ways that you can calculate domain and range, but again, if you look back at the notes on this topic, the easiest way to do it is to take what is inside the radical and set it greater than or equal to 0. So in problem 3, what's inside the radical is just square root of x. So we're going to take what's inside of that, x is greater than or equal to 0. Pretty easy as far as that one goes. Then to figure out the range, we're going to take that value for the domain, plug it back into the original, and whatever that value is would be our range. So in this case, putting a 0 back in, we would get a -3 for y. So our range is y is greater than or equal to a -3. Then for filling in the XY table, you just have to put in at least 5 total points. We already have our first one from domain range, so you can pick the rest of your X values to put into the original, use a calculator as you round them, and then you should graph the curve. So you should get a curve for each one of these. So in 4, again, to figure out domain and range, you take what is underneath the radical and set it greater than or equal to 0. So in this case, x plus 5 is greater than or equal to 0. So subtract that 5, and x is greater than or equal to a -5. When I'd plug a -5 back into the original, that'd be the square root of 0. So y is greater than or equal to 0. That gives me my point for domain and range and the start of my curve. Plug in at least the 4 other points, and then graph your curve. The thing to keep in mind for 5 is because we have a negative value in front of the whole thing, so y equals a -2 times square root of x, because that's a negative, our range, y is going to be less than or equal to a number. So that's the only time where it's going to flip. The y is going to be less than or equal to a value for the range if there's a negative in front of the whole expression. So our domain in this case, x is greater than or equal to 0. When we plug that back in, y is less than or equal to 0, giving us our first point. Plug in our 4 other points into the original. Follow the order of operations. So first the square root, then multiply by -2, and get your curve. Then for 6, because it's a fraction inside the radical, we have to set it up as x plus 4 over 2 is greater than or equal to 0. We would solve then for x, so multiply both sides by 2. Then subtract the 4, so x is greater than or equal to -4. When we plug that back into the original, that gives us our value for the range, y is greater than or equal to 0. Plug in our 4 other values for x, get our y's, and graph your curve. Then for this next section, they want you to simplify each radical expression. So this is where you'll be using the rules for adding, subtracting, multiplying, and dividing radicals, as well as simplifying. So right away with addition or subtraction, we can think of it like combining like terms. 5 minus 2 in front is 3, so it's 3 square roots of 7. In 8, this is 6 square roots of 3. Then we can split the square root of 12 into the square root of 4 plus square root of 3. Square root of 4 simplifies to 2. So it's 6 square roots of 3 plus 2 square roots of 3, which is 8 square roots of 3. Number 9, we want to simplify all the radicals first. So we want to break them down as much as possible, which you can see in step 2 here. Then in step 3, I just simplified. And same with step 4. So after breaking down the radicals and simplifying, that becomes 6 square roots of 2 minus 5 square roots of 2 plus 3 square roots of 5. 6 square roots of 2 minus 5 square roots of 2 is just the square root of 2 plus 3 square roots of 5. In 10, you have to use the distributive property, and then after that, you want to look to simplify. In this case, square root of 10 can't be simplified any further. Minus 4 square roots of 5, as simple as it gets. In 11, anytime we have a binomial times another binomial, we would want to use the FOIL method. So in this case, the FOIL, first, outer, inner, last, you'll see that the 2 middle terms cancel. So this problem becomes 9 and then plus the -5, or 9 minus 5, which gives us a final answer of a positive 4 or 4. In 12, again, a binomial times another binomial, so we have to FOIL. So after we FOIL, the first, outer, inner, last, we have 12 square roots of 6 minus 16 square roots of 2 minus 18 square roots of 3 plus 24. None of those can be broken down any further or simplified any further, can't combine any like terms, so we just leave it as this long expression. Remember to simplify any radical with a radical on the bottom. We cannot have that in our final answer, so we need to multiply top and bottom by that value. So this would become 3 square roots of 6 over 6. The 3 over 6 can simplify to 1 over 2, so it's the square root of 6 over 2. And then for 14 and 15, in any of these radical equations, remember after you solve, so if the directions ever tell you to solve, you always have to check your answer. So after we solve the equation, you'll see the steps for checking your answer as well. So originally to solve, the first thing you want to do is get the radical alone on one side. So on 14, we had to subtract the 1 first, and then we could square each side. Then it became 6x minus 3 equals 81. So add the 3 to each side and divide by 6, and x equals 14. Then we're going to take 14 and plug it back into the original equation to check the answer. So when we plug that back in, 6 times 14 minus 3 inside the radical. So 84 minus 3, which is square root of 81, plus 1. So 9 plus 1, 10 equals 10. So yes, x equals 14 is a good answer. In 15, because we have x on each side, that tells me eventually I'm going to have 2 possible answers to check. So in this case, the radical's alone, so I can square each side. And then we want to rearrange the equation so that it equals 0. So x squared minus 2x minus 3 equals 0. And then we want to factor that by undoing the FOIL. So factoring out that trinomial, it would become x plus 1 and x minus 3. So we set each one of those equal to 0, and our 2 answers to check are x equals negative 1 or x equals 3. So when we plug both of those back into the original, when we plug in the negative 1, we end up with a negative 1 does not equal 1. So no, that one is not a good answer. When we plug in the 3, we end up with 3 equals 3. So yes, our only answer to that problem would be x equals 3. So again, your quiz is going to look very similar to this review itself. What you'll want to do is make corrections to your own copy of the review, go back over any of the notes or video lessons on the problems you struggled with. Then if you're still confused, let me know before the quiz and we can go over some questions or examples if need be. Otherwise, as you do the quiz, you have all your resources available in Google Classroom, so make sure you show your work for partial credit, and that quiz will be posted for Friday's work.